the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms, this is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Okay, hello there and good evening everyone. If this thing works, then we can actually get going. And yeah, it seems it works. I can hear myself on YouTube, so again, officially now, good evening. And welcome to another of my live streams. This one is going to be the third part of the Arcane Sector Online, the making of series basically, and it's going to be probably the last episode, both of the series and of this year. Next week I'm actually I won't be doing one because I might not be available near a computer. Yeah, so today's moderator is Disconnected. You might know him from some places, but he's not a moderator that you see every week. You usually see either KrzaQ or Foxtrot Charlie, but yeah, Disconnected is one of the people who are helping me with the live stream. So thank you, Disconnected, for being here. And for all you viewers, basically, if you have any questions for me during the live stream, then do ping Disconnected, like on YouTube, type @ and then Disconnected and a question for me or a comment, and do the same on IRC, though on IRC you can actually also do !Q and then the question, and that way I'm going to actually get it. Yeah. So don't worry, it doesn't mean that today's moderator Disconnected, that's actually his name. Yeah. I'm sorry, that was probably a lame joke. Cool. So, what are we going to talk about today, and what did we talk about last 2 weeks? Basically, as most of you know, and if you are new to this live stream, then I'm happy to explain. There was a Dragon CTF, basically a CTF organized by my CTF team, the Dragon Sector, and I created an MMORPG game for the CTF so that folks can actually try to hack the game, and there were 6 different tasks for the game. And on the first live stream, I think 4 weeks ago or 3 weeks ago, something like that, we did probably 3 weeks ago, because the CTF actually took place 4 weeks ago. Anyway, I basically showed how to solve most of the tasks, and also chatted out about the remaining ones. And then next week, like a week after that, I did tell you how the thin web client was made and how it communicated with the actual desktop game client. Then I've spent last week describing how the software 3D engine which was in the game worked, and today I'm going to chat about the server side, like how does a server of a simple MMORPG game look like. And this is a really simple server written in Python. It doesn't have too much code, where pieces of the code are pretty complex, other pieces are really, really simple. So yeah, and that's going to be today's topic. So basically I'm going to show you how the network connectivity worked. I already talked a little about how the networking protocol itself looked like on the first part of these live streams, of this series, right? But today I'm going to show you the actual implementation in the client and on the server side, because let me put it like this: these are not on one side, it's not the most perfect code. On the other hand, it's not bad either, and I did use some hacks which I'm pretty happy about. And yes, these are hacks. It's not proper production code. Some of it is, but not everything. And then I would like to also say how the higher level networking code works, and then how does it happen that you actually can use an item or take a thing and put it in your backpack and so on, or even move the character around the game. So yeah, that's the topic today. Again, if you have any questions, then do let me know. I know that actually this connector is having some problems with our question dashboard. So you can probably wait a few minutes before asking the question. Okay, so let me move to the desktop, and it's actually the proper desktop now. Okay, this is Disconnected's blog, and he actually posts stuff from time to time. For example, last post was a month ago, reboot your PC from a Docker container. Yeah, I actually was on the Put Security Day. I also had a lecture there, so I remember Disconnected's talk about Docker security, and I guess you can also read a little about it in this blog post. So do check it out. It's Disconnected 3D, like by 3D, like disconnected with 3 instead of E, and .pl. So that's it. Okay, I'm wondering if I have anything interesting to show you today. I usually start the live stream, 15 past, so everyone who wants to watch it and is still running late can actually go and can come and watch it from the start, unless they're super late. In that case, well, yeah. So this is the current CTF time rating for this year. We have our team on the first place still. PPP really close. It looks like 50-point difference, or like 60-point difference, but it's really close. PPP is an amazing team. And Tokyo Westerners is actually on 3rd place and P4 on 4th place. So and these teams, like the following teams, are also super close. Now I'm mentioning this because there is one major CTF left in the season, and that's the Chaos Communication Congress CTF, which is 35C3, which is, as you can see, it has a rating of 100, which means the first place gets 200 points. So that means that if PPP gets first place, they're the winners. If probably, unless there's some complicated math here, but yeah, probably they would be the first place overall this year. If they don't, then if we get a high place, then that should be enough for our team to be on the first place. So it will be an interesting season finale, basically. But apart from that, here, these teams, like, this can totally change in this season. Like, if one of these teams gets the first place, then this is going to reshuffle really hard. So any of these teams are still in for the race to get the 3rd place in the season. So the CCC CTF was always an amazing CTF, and it was the worthy season finale of the year. So I'm really looking forward to it this year, especially that it has the rating weight it deserves. So this is going to be fun. If you play CTFs, then best of luck, good luck, have fun. It's going to be an amazing tournament. If you don't, well, the CCC is a rather hard one, but I did hear that they might have a beginner CTF as well running in parallel, so you might want to check it out, because it will be a good opportunity to start. Okay, so yeah, again, like, there's also second finals, but I don't think the second finals are going to change too much. But perhaps we're going to see. They don't have a huge rating weight, so yeah. So we'll see. Okay, so this is how the CTF scene currently looks like. I'm actually quite excited about it. Now, I guess we still do not have... we still do not have... oh, we have the questions. Perfect. So, there's one question. The questions will appear... Wait, they will appear somewhere there. I have the camera actually inverted here. Oh, the question is still not there. Why is the question still not there? I don't know, whatever. Christian writes, can you tell some of the useful tools you installed on your PC, maybe for reverse engineering and web exploitation? Okay, that's a really good question actually from Christian. So for reverse engineering, I have the usual stuff, which is IDA for, well, for basically everything related to static code analysis. I use IDA only for static code analysis. I know it has a debugger. I do not use the debugger. I also have Binary Ninja for that. I do not have Radari, but you might want to check out Radari too. R2 is gaining popularity, though it has a little different approach than the two aforementioned tools. Apart from that, a debugger. It depends on what you are debugging, but you do need a debugger. I do have several of those actually on Windows. I do have like 2 versions of OllyDbg. I have GDB for Windows with Python installed. I do have WinDbg or WinDbug for Windows debugger for Windows for some other stuff. So yeah, this, and for like Linux GDB with like scripts like PwnDbg, for example, which are pretty useful. Apart from that, I do not have too many tools. I do have on Windows the Process Explorer and Process Hacker. These are basically like task manager on steroids, which means that you can learn a lot about the processes which are running on your system. So if you're reverse engineering something and you can actually run it on your system, then you can use one of these tools to basically like, for example, show you which libraries are loaded or in that process, or how many threads it has and where the threads are actually at, if they are locked, for example, or which files or IPC mechanisms does it have open. So it's like a task manager, but it's still pretty useful. Apart from that, I have a process monitor. Process monitor is both Process Explorer and Process Monitor are actually tools from sysinternals, which was acquired by Microsoft, so you can find them on Microsoft's website. And Process Monitor is basically like strace, but for Windows. Though strace on Linux is used for tracing syscalls. That's why the S letter is at the beginning. Now, a Process Monitor is actually running on a little deeper in the system than syscalls. So it's on the like a filter level in some drivers or some driver stacks actually. So it doesn't show you syscalls, it doesn't show you API calls, but it shows you quite a lot of information related to what a syscall would be. Like basically the thing that a syscall involves is what the invokes is what the Process Monitor shows you. So these tools, and apart from that, also I find it useful to have a tool which displays you basic information about executables. On Linux, that would be like readelf or object dump. On Windows, it might be I have PEView. I know Hasherazade, actually, she created pretty good tools for viewing PE, and so you might want to check out her stuff. Apart from that, yeah, I think that's and a decent hex editor. Obviously, I use Hex Workshop myself. I find it really good. It's not super expensive, but it's not a free application either. Yeah, so that's it for reverse engineering. Apart from that, like Python, basically, and Python, Unicorn, Capstone, and Keystone. These are like the 4 things I use together quite often, and Z3 for SMT solving, which is also sometimes useful for when you're doing some reverse engineering. And Wireshark for network protocols, obviously, and Network Monitor. Okay, so that's it for on this level. For web, because I guess the second question was about web exploitation. Python. Python is my #1 tool for web exploitation because I actually do write a lot of short scripts when playing with websites. Apart from that, a web proxy, like web debugging proxy, whatever you like. It can be Burp, it can be Zap, it can be Fiddler. I personally use Fiddler, though Burp is actually amazing as well, so you might want to check that out. And Network Miner, which I already mentioned next to Wireshark. Network Miner is what it does. It's actually you give it a pickup, a network dump, and it does a higher level analysis on that, and also like does, I'm afraid to use the word, but some like data mining. So basically you have, for example, a table which displays you all the cookies which were in all the sessions in pickup. So that's sometimes pretty useful. It's more of a forensics tools than a network, like web exploitation tool, but it's still useful. Apart from that, Chrome, and sometimes I feel I need to write a Chrome extension to do something specific, but that's about it. Yeah. Then, okay, next question. Now I see why the questions don't appear, so they should appear now. What do you think one high school student should start with if they're looking to get into cybersecurity? It is a good question. You should try different things at the beginning to know which exact area of security is interesting for you, because there are many areas of security, like there is cryptography, there is web security, there is low-level security, there is hardware security, there is forensics, there is mobile security, like network security, system security, and so on and so on. So try different things and see what you like the most, what like basically speaks to your heart, and then focus on that. And then actually this is the moment where you should ask the second question is, how do I start with X, right? So if that would be, I don't know, like reverse engineering, you can check out my blog. I do have a blog post about it. Let me show it to you. So if we go here, I can mention that in a second. Let's look for FAQ. Yeah, so I have 2 blog posts. One is how to learn reverse engineering. It's actually a pretty long blog post. You might want to check it out. I try to approach the subject from different like vectors, but it's not a tutorial on reverse engineering. It's a question. It's a blog post answering the question how to learn it, which is 2 different things, right? It's not a tutorial. It's basically points you at some tutorials and tells you might want to try this, or you might to do that exercise, or you might want to check out this website. So that's one thing, and I can give you a link to it. And then by the way, if you think my room is a little crooked today, that's I'm sorry about that. My camera is has a weird angle, but I don't want to try to even fix it because it's complicated. Yeah, and then I have another blog post which is called how to find vulnerabilities, and this is actually how to find vulnerabilities, how to do security review of a product. It's also not a tutorial on how exactly to find vulnerabilities, but it tries to answer the question of how to basically start learning that topic. So if you're more into like cryptography, or if you're more into forensics, for example, then yeah, I don't really know. I mean, these are not my main areas of interest. So, but if you're into one of these topics, you might want to check these out. Okay, one more question and then we can get going. Yeah, basically today, the last question was actually about my camera not being straight, but yeah, it's not really helping if I try to move it. It's complicated. I actually have a camera which is in between my 2 LCDs, so it's like the camera is here, and if I have the LCDs at a weird angle, then the camera is at a weird angle. My apologies. I will try to fix it for the next live stream. Cool. So I guess we can get going with the original topic, where the original topic was Arcane Sector. Okay, so let me actually start the server and run the game, just in case there is somebody who didn't see Arcane Sector before. I know I'm actually spamming my blog and my Twitter and whatever about the game. I'm pretty proud about it, actually. It took me 2 months to make it, like every evening, almost every evening for the 2 months. So yeah, there you have it. That's why I'm actually talking so much about it. Please give me a second. I do need to fix one thing because my terminal for Windows actually has 2 different profiles, and I forgot to load the big font profile. Yeah. So okay, this is the server. Let's run the server, and now let's run the game. You can, by the way, find the game, as you know, on my GitHub, right? I still didn't decide on the license, but I'm pretty sure it's going to be like BSD style and mid style. So yeah, I will try to update the license in next few days, in case you want to play with it. Okay, so I think it's 2 and then yeah. Okay, here we have it. Okay, yeah. So this is the game, and yeah, I already, I guess, told you last time, but the door here is actually, it's complicated. It's not a real item, and the game thinks it's an item and tries to display it again. But whatever. So this is how the game looked like. It's like an old school RPG, and yeah. And I already told you how everything on the screen is rendered. That was last time, and I guess I can, and I told you about the tasks which you had to do in the very first live stream, which was basically part 0. So today we are going to talk about the server, which is this stuff which is outputting the random messages here. Were random looking. These are obviously not really random. Cool. So let's go to my GitHub. Okay, then you need to go into repositories and Arcane Sector. Yeah, and now if we go to, I guess like the main page is actually a README file with all the packets and so on, and I already showed them to you. So just to, I guess I'm going to show it a lot today anyway, but just to give you a hint on how to remind you how the protocol is constructed. Basically I'm using TCP, which means that it's a stream protocol, which means if I want to send packets, I do actually need to introduce a packet mechanism into TCP, and the usual way you do it is you basically declare the length of a packet, and then the other side is going to read the length first and then know how many bytes to read, to receive, until it gets a full packet, and then process that part of data as one packet. And then it reads the size again and some more data to get the next packet. So this is a pretty common way to do it. Now, yeah, and this is the size. It's a 32-bit size, so the packets can be up to 4 gigabytes. That's actually not true. The server, if I remember correctly, limits them to be rather small. I don't remember if I set it on like a few kilobytes or a few megabytes, but something like that. Then a typical way also to do it is to include a tag or a chunk ID, a packet ID, basically, which tells the other side, like the receiving side, which how to process the packet, what data to expect later on. And then there is the packet ID, which is basically sometimes used if I send a request and to the other side and I need to reply, but I know that I will be receiving other packets in the meantime, so I need to know when the reply arrives and that it's actually a reply to a given request, and the reply will just have the same packet ID as the request. And it's a 64-bit unique ID, basically, so it's supposed to be unique as in per client. Yeah, okay, I see the limit is 1 megabyte. I'm actually not sure if that was how it was implemented. And then every packet, depending on what packet is it, has its own data. For example, data can be just 1 byte. For example, if the character the player wants to move, then the client sends a packet to the server with the chunk ID or packet ID move, and yeah, and basically the 1 byte is basically just the direction. Where do you want to go? Do you want to go forward, backward, or do you want to strafe left or right? I did describe the rest of the protocol basically last time, so I'm not going to go too deep into it now, but I guess since we are going to look at the networking code, we do have to look at it a little. Okay, so let's start by looking at the networking code, the low-level networking code, which is creating the packet and parsing the packet. And I'm going to show you how it looks like on the client side, how the packet is created and then on the server side how it's parsed and how it's basically how do you move from the bytes into actual an object of a class of a packet type. And then the other way around, as in how the server side creates a packet and sends it to the client, and then how the client parses it. Because I'm going to spend some time on it because it's actually a common place where folks make mistakes, and I think I didn't make a mistake. My code isn't beautiful, but I think it's actually decently constructed, especially about receiving packets. Cool. So first we go into the client, and then there is a file which is called packets. Yeah, well, two files actually. And then there's also parser helper, which we will get into later. So I'm going to open the header file first. So this is it. Yeah, I guess this message is not really true, because I did have to do two reasons: do a proper header from this file and actually have a CC, like an implementation of the classes listed here in a different file. Initially, I thought I would just have it in one place. So yeah, this is basically the C++ definition of, of what I've shown you here, right? Yeah, this is exactly it, the common part, the size, the chunk ID, and the packet ID. Now I'm using attribute packed here, which isn't really necessary because for these sizes it will be fine. It will be okay. It will work correctly and it will align correctly. There will be no padding in between the fields, but just in case I wasn't really sure if I'm not going to add anything or change anything, I did add this attribute packed, which means basically tells the compiler do not insert any padding in between the fields. Yeah. Now, please note I am going to use bytes t as a vector of bytes, basically. So, first let's look at the class which is actually sending the packets, and that would be packets CS, client to server, packets sent by the client. This is the main class, and then every packet type with a distinct chunk ID is basically inheriting over the main class. Now, the main class doesn't have too much stuff going on for it. It basically has two virtual functions, or actually this is like an interface which needs to be provided, and that would be get chunk ID. So a given class is supposed to return the chunk ID it needs, or it actually describes. So let me maybe open this file as well, so we can look at the implementation at the same time as we look at the definition, the declaration. Sorry. Yeah. So we're looking at packets CS. Yeah. Enter. Yeah. So this is like super simple. Just return whatever, and it returns the string. This is a string. Even if it looks like returning a pointer, it's actually returning a string object. So this is implicitly turned into a string. Now, so that's one thing. The other thing is a build, which is a rather special method. If I remember correctly, it's actually being invoked by the only implemented method in the mother class, in the master class packet CS, that would be send. Send takes a network socket, and this is a network socket which you use to basically operate on the low-level sockets, right? And send is supposed to take a packet, build it, like take a packet which has some data, put it on a binary level in a byte protocol, and then send it through a socket which was provided, and return whether the sending was actually successful. So to do that, what the send does is actually it's not super complicated. It basically calls build on the packet. So the way you use it is you create a packet of, an object of, for example, this type. Then you fill all the fields, and then the build method, which is overridden by the inheriting class, it's supposed to prepare the prepare the payload, the byte payload, and the byte payload is actually here. this is a vector of bytes, and the build method is supposed to extend the vector of bytes size to be the proper size that the packet needs, and then fill it with data, basically serialize this data, which is in a custom struct for each and every packet, and then the send can continue. So after it's built, then it initializes the common part, and the common part would be the chunk ID. So this is where the get chunk ID comes into. It just mem copies it into there. Then the packet size, or actually the payload size, because it's only the size of a payload, is without the header. And then also the ID. The ID can be set, but it doesn't have to be set. It's pre-initialized to 0. In most packets, it's actually not set because it's not really important, but it can be. And then it sends all. Please excuse the name of this method, but it actually sends all the bytes to wherever, and first it sends the header, which has the size of the payload and also the chunk ID, and then as you can see here, it sends the full payload. So basically it takes the size and then send data of the size, and if something went wrong, then it returns false. So each and every packet has something like this behind it. So that means that for each and every packet I have for each and every packet class, and there are like quite a lot of classes, right? I had to implement a separate class where the separate class had to implement this build method. And this is only for packets which are outgoing. So there is no parsing of packets here. It's only for outgoing packets, the packets which the client sends to the server. And now if we look, for example, at how the build is implemented for the enter. The enter is basically a player wants to enter the game, so it sends, the player sends a player ID and also the password for the given account. So if we look how it's implemented, it's actually pretty simple. It just, well, in this case, and this is not beautiful code by any means. It shouldn't be. It should be probably coded in a little better way. But what it does, it resizes the payload to the vector to be the size of the struct, and then it just copies the the structure, right? The instance of the structure, which has been pre-filled. Now, each and every packet class has a factory. Now, a factory is a static function which basically takes the arguments which normally a constructor would take them, and then it allocates memory for the new, well, basically creates a new object and pre-fills the fields, and returns a unique pointer in this case, or it could return just a pointer, but I actually wanted to be sure I don't leak any memory, so I tried to use unique pointers wherever I could. And in case of this, again, of this enter packet, it basically goes like this. It calls make unique, which basically it allocates and like calls the constructor and so on for the packet, and then it initializes the fields. It initializes the password field, and it initializes the what else? The player ID field. Yeah, and that's basically it, and it returns the unique pointer. So if one wants to use it, like actually send out a packet of this type or any other type, that's actually how it's see how it's done. So let me find where it's used. Okay, so it's used in the client.cc file. If we look here, this is basically the beginning of a networking sender thread where the player wants to log in. It calls the factory, it provides the config, the password which is taken from the config. It takes the player ID, and this method here will return a unique pointer. And then on the unique pointer, we call the send method, which takes a socket. This S is a socket, and it basically will call the build, which will prepare the payload, and then send out the bytes on the socket itself, on the wire, right, on the network. And yeah, it returns true or false. So basically this boils down to using each and every packet in this fashion, which is basically an if with a factory code, and then we call send on it. And it's actually surprisingly convenient to do it like this. Later on, it actually switches to a different model. This is probably the only packet which is called like this, maybe not the only one, but one of the only ones. And later it switches to a mode where the thread, the sender thread, is going to grab a packet from a queue, because other threads, there might be multiple threads which want to send the packet, and you do not want two packets to be sent at the same time, because that means that they will, like, the bytes might actually interleave, and that will make absolutely no sense to the receiving side. So you want to have a synchronized queue somewhere where other threads, if they want to send a packet, they put the packet on the queue, and then you have a sender thread where the sender thread actually checks if there's a packet. And if there is not a packet, there is no packet on the queue, then just sleep. But if we actually get a packet, then it pops the packet from the queue, removes it from the queue, and then it checks if it's actually a packet, because reasons. And then it just calls the send method on the packet, and that's it. It doesn't even have to know what type of a packet it is, because of the way this inheritance works, right? So yeah, I'm pretty happy with this code. Yeah, this is, I guess, another packet which is called actually by name here and not created somewhere else. So this is how it works, how the packets work, the sending on the client side. So now let's go to the server side and look how they are received. And this is where things get a little funny. I'm going to check if there are any questions right now related to the to this. The best supervisor writes, would you trust C's built-in types like char or int in real-world projects as well? So that depends on the context of the question, but these are well-defined types, and sometimes you prefer to use them, and other times you prefer to actually use stuff like uint8, right? And the distinction here is that if I need to have guaranteed the size of a given variable because it's related to a wire protocol or a file format, then I'm going to use types which actually have the size declared in them, which guarantee me the size. And that would be like uint8 instead of unsigned char or unsigned char, right? But there are other places where, for example, I want to do some calculations and I know that int might be enough for me, and I don't really care how large is the int, because it might be an int like 16-bit int, it might be 64-bit int, I don't really care. And I want and int is actually a kind of magical type, because it's supposed to be the operations on it are supposed to be fast on a given architecture. So yeah, so I prefer to just use int. And yeah, that same goes for example, for char or char, like, the character type. If I'm operating actually on normal ASCII characters, then I will use that type. If I want to use UTF-8, then I will probably choose this one. Or if I want to use it as a numerical type, then I will explicitly write signed char or unsigned char, because these are actually three different types. So keep in mind that in C++ and C, char, unsigned char, and signed char, these are three distinct types. Even if char is usually implemented by either signed or unsigned char, you don't know that, by the way, this differs between implementations, then yeah, these are like on paper, at least on the specification, these are distinct types. So it depends. How many lines does this file have? Are you asking about these files? Let's see. These aren't too long, like 300 lines, and this one has 400 lines. So these aren't the large files in this project. Okay, and now let's look at the server implementation of it, which basically is the packets.py file in the server directory. And I'm going to start with the let's start from the top maybe. This is the master class or the mother class for the parent class for the packets received by the server. And what this is supposed to do is supposed to first, so it's kind of funny, and I'm not super happy with how it's done, but it takes a socket. So the receiving thread, basically what it does, it says, hey, get me the next packet. And the constructor is going to be called here with a socket. So the socket is supposed to receive a packet. It's going to, well, the constructor, right? And the other stuff. Now, what the constructor does is it receives the common part. So it basically receives 16 bytes to get the initial header. Sorry. And the initial header contains, again, the size, the chunk ID, and the packet ID. And once it has it, then it checks, well, is this a chunk ID that actually should be received? It would be quite funny if, if I actually keep separate sets of packets, like one the receiving packets, which I can receive, and the other one outgoing packet, which I can send. And yeah, I'm checking this is actually a packet I can receive, I as a server, right? If no, throw an exception, because reasons. And throwing an exception in this case might actually kill the connection, like somewhere higher on the stack, and I'm totally happy with it. If somebody sends a malformed packet, if the packet is like not proper, then just cut the connection. It doesn't make sense trying to recover a broken communication protocol. And this is one also of sources of errors in parsers that you try to recover if something is broken. Never recover. You detect an error and that's it. Like, done. Kill the connection. Like, the connection is just throwing garbage at us. It doesn't make sense to try to recover the situation. Yeah. Basically, if you're writing secure code, never try to recover from a malicious input. Always just say, no, this is evil input. Just done. Anyway. Yeah, and this is where things get a little funny, because at this point, actually, it checks if it's actually the master class or if it's actually one of the classes which are inheriting over it. And if it is another class, then it checks whether the name of that class actually matches whatever chunk ID we get. So this means that in the Python source code, I have to name classes in this way: packet CS and then the chunk ID being enter, for example, right, for the packet we looked at. And this has to be the chunk ID. It cannot be anything else. It cannot be like, I don't know, login packet or whatever. It has to be enter. Because otherwise this check will fail and the trick I want to do won't actually work. Now, if we actually look where this is, well, whatever, I'm going to look at it later. Anyway, so then it receives the rest of the packet. If the packet is larger than the limit, then whatever, and then it calls the parse method on the data, which is supposed to take the binary protocol and put it into the fields of the class. So basically do the exact reverse of what is happening in the C++ code. And well, by default it does nothing because, yeah, I mean, by default you might get a packet which doesn't have any data, so you do not have to parse anything. Just the fact that the packet appeared might be meaningful in its own, right? For example, the packet might be goodbye because the client is disconnecting, right? Now let's see how it is actually called, because there is a method called this is for initializing the packet library. Yeah, packet receiver. And this is where, yeah, the hackiest of hacks. This is quite funny because it first calls the method on like this. Like, here's a socket, just receive it. And then it receives the common part which has the chunk ID. And it also verifies the chunk ID. Now, once it does it, then it actually, based on the chunk ID, it gets the proper class from the, like a class object from a list of classes, from a set of classes, well, dict of classes actually, a dictionary of classes, and it overrides the class field inside for the object. That means that the object suddenly changes from being of the class packet CS to a class being, for example, packet CS enter, or packet CS goodbye, or packet CS whatever. This is probably not doable in C++ at all. No, it's not doable in C++, I'm pretty sure about it. Well, maybe. But yeah, basically, it's partly doable. Never mind. It's doable in Python. It's not beautiful code. It might not work on any other implementation than CPython. But in the end, what happens here is that I had a pre-initialized packet with the payload and with already read data from the socket. And then I'm switching the class of it, and I'm calling the parse method of the new class, not the empty one, but of the new class. So let's look how it looks like on, for example, for the enter packet. This is the class, and it overrides the parse method, and it actually just, you know, unpacks 32 bytes and then another byte. So this is the password which the player provided, and this is the player ID. So yeah, it's like overwriting a vtable pointer, as KrzaQ says, but the difference is that in C++ it's not always enough to overwrite a vtable pointer, because in some cases it might be ignored. Like if you're and here is like it totally changes what class is this, and yeah. But yeah, it's similar to overwriting a vtable pointer. Okay, so yeah, this is basically how it's received, and then this method, the packet receiver, returns a packet. So you might imagine that this method is actually being called in a loop in a receiving thread, and it gets a packet each time. And then when it wants to send a packet out to the client, like for example, tell the client, I don't know, like there's a new update your inventory because you have a new item, or for example, you logged in correctly, or for example, somebody near you texted you, like send you a message, a text message, or you hear them say something. Then the server needs to send that packet and needs to construct it. And to construct it, it's actually pretty similar to the way it was done in C++. There is a master class. This one has SC, which means server to client. And it only has like a send method, which basically checks whether there is any payload. And if there is any payload, then yeah, it assigns it to a payload. And then yeah, it checks whether what should be the chunk ID. So in C++, there had to be this method called getChunkID. In Python, it doesn't, because I'm just like using ugly hacks and to rip out the name of a class and to get the chunk ID from the name of a class. So again, the name of a class has to be meaningful. Then yeah, it checks if there is a field called packet ID. If it is, then it sets packet ID to it, otherwise it's preset to 0, similar as in C++ again. And sends the header, no magic here, just like standard pack with the fields, and then sends the payload, if any. So if we look, for example, at, I don't know, what like position change, so that would be posi. Yeah, this is yeah, this packet is basically sent where a player is being moved or teleported somewhere. For example, a player requested that they want to move forward, and then the server will send them an updated position and tell them, yeah, you are now on this position. So it basically has only the coordinates, and it also tells the player you are looking in this direction, or you are looking in that direction. So if we look at posi, then there's almost nothing here, right? Instead of using a factory, I'm actually using a constructor in these cases, because in Python some things are a little easier, you know, no managing of memory and so on. And yeah, it just sets the payload to a bytes object containing this packed data. And then again, the send is being called, which we saw already, and it's going to construct the header and then send it out with the payload. And we go back again to the C++ code. And in C++ code, we have this. No, this, not this. Here. The basically mirror of the class family we saw in case of the client, which is basically packets which are sent from the server to the client, which means this code is receiving. And well, I cannot do the same trick I did in Python, so it has to be a little more complicated, obviously. There are, some methods. One is supposed to receive the header, and the other is supposed to receive the payload, or the packet. I guess the packet would be, in this case, both the header and the payload. And I guess this is distinct because I first need to get the header to be able to know which object of which class to create, because for different packets I need different objects, and that actually has to be done manually in C++. There is no hacky way as in Python to do it. Then get chunk ID, same stuff, and parse. And parse is actually which I'm going to go a little deeper in. And there's also like receive to actually get the data. Now, if we look, for example, at the implementation of the position one, or actually the declaration of the position one, it has some fields related to the position, for example, position X, position Y, and direction, as we saw in the packet description, and as we saw in the implementation of outgoing packet. And it also implements the get chunk ID. This will just return these string with these letters, so that's boring. And the parse method, which is supposed to take the binary protocol and then actually parse it and fill these fields with proper values taken from the packet received. Now, if we look at the parse in this case, so we need to go here, then it calls some methods which are like p read uint16, p read uint 16 again, and then p read uint8. No error checking here, only error checking, or actually not even error checking, is just returns whether p, whatever that is says everything was fine or not everything was fine. Now, one problem, I guess, with parsing is usually that you run out of data, for example, right? And so you move past the string, and then buffer overflows start to happen. So I didn't want to introduce checks with each reading, like every two bytes. Like here, I have to read 2 bytes, so I would need a check to check if 2 bytes are available. I would need to check it. If no, then throw an error, and then the same for the next field, and then for the next field, and so on and so on. And I didn't want to do it. I actually wanted to just tell the parser I need these values, and the parser would return 0 or the value. And if the parser would return, that doesn't matter. If the data would run out at some point, then the parser would have an internal flag saying an error happened, and at this point I can check it and detect it, like at the very end. So I have really short code, which is at the same time secure, because the parser internally takes care of all the sizes. I just need to prepare the methods for reading each distinct type of a packet. And this is done in the parser helper, basically, file, which looks like this. This is a parser class. It basically gets you give it a buffer, and it operates on that buffer, and the buffer is going to be, does it even copy the buffer? How does it work? Yeah, it's just a reference. It's basically a view. A parser basically is a view on a buffer, which means it doesn't own the buffer, it just goes through the buffer. So the caller needs to make sure that the buffer does not magically get deallocated while the parser is running, because that would be really, really bad. That would be a use after free, and we do not want that. But due to how it's usually constructed, that was not an issue. That was never an issue, but yeah, there it is. It also has the size of how much data is there. You know, I guess it could use just data.size each time, but that's almost the same thing. And also the index, where is the parser, where is the reading caret on the byte stream while parsing the data. And then again, there is this error flag, which is set if we run out of data while parsing, otherwise it's not set. So if we have, we are using, for example, this method there, and this method is just calling, there is no error checking here, as you can see, it just calls like uint8. So I actually needed to, and yeah, it calls, well, because if I want 16 bits, I can read 2 times 8 bits, and I can just concatenate the value using Boolean, or actually not really Boolean, more like bit logic operations. So that's what I was doing here. And that means also that I just need to implement that error checking here, and this is the largest function, basically checks if already an error happened before, then yeah, like return 0, whatever. Otherwise, check if there is, like, if you still have a byte available. If you have it available, then read it. And as you can see, I'm using also add here. Add would actually throw an exception if I would fail at my checks. So that's another, I guess, like defense in depth. Like, that's really defensive coding right here. And it returns the data. Otherwise, if there was not enough data, it sets the error to true. And this allows for lazy error checking. Again, I just need to check at the end of parsing, or actually of acquiring the data, at the end of acquiring the data, if everything was fine, and I return 0. Actually, this is like a really simple construct, and this class is really simple. Then each and every class can be implemented in a similar fashion. I trust the compiler here to actually do the inlining if that's feasible. Otherwise, the packets are rather small in this game, and I don't mind some cycles which are going to be lost here because I'm reading like 1 byte at the time. I'm pretty sure actually the compiler will optimize it anyway. So I'm not too worried about speed here. And then, well, yeah, this might be a little painful. Yeah, reading strings might be painful. That's why I actually, optimize it here. And I'm getting more data than just 1 byte at the time. But the rest uses the same methodology. And thanks to that, thanks to how the parser is constructed, every parser for a given packet type looks like this. Like, just read this, read that, and check at the end, like return if everything was fine. Lazy error checking, I'm quite happy with that. Okay, so yeah, so that's how receiving works. Now let's move to up the stack in the Python code, right? So we know how the packets are received. Now, how is the connection initialized? Because in case of a server, there's actually one funny thing, and that is of this type of a server. If we have a player, right, which is playing the game, and the player has like some account, we probably don't want 2 connections to be associated with the same player, because that would mean that 2 players are sending commands to control 1 character. That's kind of weird. We don't want that to happen. That might cause a lot of issues and probably would not be fun to play. It might be, but probably no. So that would actually, surprisingly, it would still work on the way I designed the game engine, but that doesn't matter. But yeah, so what I wanted to do is I wanted to somehow make sure that one connection is, one player means 1 connection. And that means I had to establish a session mechanism which is kinda aware of which socket is being currently used. So it works like this basically, but when a player connects, then the server checks whether there is already a connection established to this player ID. If the connection is already established, then it kills the existing connection, because maybe like somebody disconnected and wants to reconnect, but the timeout didn't happen yet, so it's a dead connection. And then it assigns the new connection, the just arriving connection, to the same player, and it remembers that that player is actually this network connection, this socket. So yeah, that's how it works. But sounds super easy, and it took like a surprising amount of weird looking code to actually implement that. Yeah, because you know, when you so it's like this. I did already, I guess, some time ago explain that there are different approaches to servers, to sockets and servers and threads, and I usually use an approach where for each socket, each connecting socket, I have a sender thread and I have a receiver thread, because that's the easiest way for me to write the code. The code looks pretty nice. There are some problems with that, but apart from that, that actually works pretty well. So, sorry. So yeah, so if a player connects, then that spans two threads, a sender thread and a receiver thread. And then if another session connects to the same player, well, before that happens, it actually gets also its own sender thread and receiver thread. So this is like TR. And it needs to terminate these threads, but these threads might be at whatever state, right? Because this is, you know, it's a separate thread. It can be at any point in time at a different location in the code. And also this might be like maybe it just closed the socket, and yeah. So I need to somehow, in a synchronized way, from one of these threads tell these threads, please die. I know it sounds terrible when taken out of context, but yeah, like please disconnect and just go away, because you are no longer needed. And everything had to be designed in the way that whenever these threads are killed or disconnected, then they actually do not have any state. No data is lost, and all the data was probably already processed and so on. So yeah, that takes some amount of synchronizations. There are some logs here, some flags which say whether something is disconnected or not. Then I need to remember that, for example, shutdown might throw an exception if the other thread already closed the connection due to reasons. So yeah, it's a surprising amount of code to get it right, and I think I kinda got it right, but I know there are still like some race conditions where some exception will be thrown, and thankfully it will be caught somewhere else, but it's not the most elegant, you know, of outcomes. You probably don't want some random exceptions to be thrown which you do not control. Okay, so yeah, let's look at the server itself, like from the. Let's go from the top. When the server starts, it loads the config. Now, the config has, you know, the passwords, for example, and currently I do not have implemented any storing of the world. Like, you know, like if I restart the server, everything like is lost. All the state is lost, because for the sake of the CTF, that was never needed. While the server is running, then everything, you know, the state is kept. So you can get disconnected, reconnect, and you still would have your stuff. You still would be at the same position. But yeah, it would be somewhere around here where the state would be loaded, but it's not. When it's loading the world. The world is actually the world map and the definitions of where the items are located, or actually where the spawn places for the items are located. We already talked about how the map looks like, I guess, in either previous or two 2 episodes ago. And then it starts the networking, which is pretty common. It creates a network socket listening on some server, on some port. It was like 5001 if I remember correctly. And it can have at most 123 awaiting connections, not accepted connections. There can be more, but awaiting connections. And it goes into a loop, and it basically accepts a connection, and then it creates a new thread to handle the connection. Only one thread at this point, only the a dual purpose receiving sending thread, but is going to end up being the receiving thread at some point. And it starts it, and yeah, let's see what's happening there. So when a new thread is created, the sender thread does not exist yet, but the receiving thread is basically a master for the sender thread, or it's actually like a manager of the receiving thread. That's a better word in this case. So it's managing it. Then the player ID is also known, but at some point the thread will be tied. The threads will be tied to a player ID. If a player logs in correctly, then the player ID field will appear here, which it's a little. There's a little disconnect here because the player ID, the networking code needs to know the player ID. That's kind of weird. It shouldn't be this way, because the player ID is something more known to the server, like the world, the game world, but not to the networking code. Networking code is a really low level, and like player ID should be something which is like only exists on a higher level, higher on the stack. Though for reasons I did include it here, so if a player logs in, the threads will actually know that. Which player was it? I think I was using it mostly for debugging purposes though. When the first disconnect function or method actually is, I already showed you, it's being called by a different thread. It's never going to be called by this thread, it's always called by a different thread. So yeah. And then we have the run. This is what gets actually executed. And the way it works, this is just like some statistics on like how many players we have active. It sets a timeout for 2 minutes, which means that if no packets come in from the client for 2 minutes, just kill the connection. The client, on the other hand, is supposed to send a ping packet every 30 seconds. So there's that. So in normal work, if the network connection is fine, then a client would never get disconnected. If the client is running, then I can all the time be logged into the game. And that's fine. I'm not using, this for like a couple of minutes, and I'm still logged in. So that's actually fine. And then basically this is something I believe I might have shown you, or maybe that was on a Polish stream, whatever. Usually this is the way I like to write networking code. I assume that everything like, parsing the packets and so on is done in this method, which is called worker. And this method at any point in time might actually throw an exception due to not enough data being available on the socket because the socket disconnected, or maybe there was an error with the socket, or there are actually like quite a lot of different things which can happen related to being disconnected on TCP. There are like different errors which can happen in this case. So so I have this like really huge except block which catches different types of exceptions, and thanks to this I do not have to worry about error checking for networking code here, because I know that if anything happens, then the code will end up here. Like, it will end up here because the exception will be caught here. I also can assume that if the worker exits, then the connection closing will be taken care of. So I can basically return from this method at any point in time, and still don't worry, like I do not have to worry in that method about closing the connection because it will be handled here. Yeah. And here, this is actually closing the connection. So I check if it's not shut down, and if it's not shut down, then I shut it down, because again in TCP the proper way to close the connection is to shut it down first, like both the receiving, which is read, and writing, like read-write, both the receiving and outgoing side. So you close it, and then you shut down it, and then you only after you shut down it you can close the socket, because just closing the socket doesn't tell the other side, hey, I'm actually disconnecting. Which leads to timeouts on the other side. And finally we close the socket, so we destroy the file descriptor which represents the network connection, because that's what the socket is at the end. And release the player session, which is what I said is basically that if that each player has a network connection it's tied to, so this is exactly a player session in this case. And it says that it's no longer this object, this networking object is no longer responsible for this player because the player disconnected. So like there might be just no session. If the player connects again, then they will be registered. There's actually an acquire session somewhere. I think it's at the beginning of worker, because the player needs to log in to be able to connect the networking connection with a player session, with a player account. And this is just for debugging. So all the juicy stuff is being done in the worker method. If we go here, at first, well, it expects to get this packet. This is the first packet which the client needs to send, and this is the login packet. And basically the connection needs to be authenticated. And so this again will, as we saw before, this will basically receive a packet, and once it receives the packet, it will establish what kind of a packet it is based on the chunk ID, and it will switch the object from being of the packet CS type to being the packet CS enter type. Well, in this case it won't switch it because it's actually, I'm calling the proper constructor, so it will just figure it out. It will go the other branch in that code which I was describing before. And then gets the password basically. So I hash the password to be honest, for the sake of a CTF, I don't even have to hash it because whatever, right? For a proper server here, I shouldn't use just hashing. I should do a more complicated way to store the passwords and hash it, but like 1000 times using some password-based key derivation function, and so on and so on. So this is basically subject to change. This should be changed. This is okay for a CTF, not for a production level server, right? This is not how you store passwords in just a hash. Hash is a good start, but there are other stuff like source, like encryption, and so on. When I check, hey, is the password correct? Now, and this is exactly where this code should not be. Because again, the networking code, knowing something about the players and the passwords and some database for the player's passwords, this shouldn't be here. This should be on some upper level stack, but again, the game was created for a CTF, so whatever, it can be here, just for the simplicity of the code, because putting it here does simplify the code quite a lot. Okay, now the player successfully logged in, so I can get the player ID and I can actually acquire the session, like connect this object to this player ID. So if the next connection comes, for this player, then I can actually disconnect the first connection, which happened, the prior connection. Also doing this, and then this is again code which should not be here. It's checking if a character is actually created, because a character, when you first log in, the character is not created, and therefore the server sends a no PC, like no player character found under this slot. So and it expects my PC, which basically gives the character name to the server, and the server creates a new player with the assigned player character. And again, this code should not be here. It should be on some upper layer stacks, not related to the networking code, but they are here, so whatever. And this method totally should not be called here, like create player. There might be a race condition. I don't think the race condition is actually likely, where two connections try to create a player at the same time, but actually, since the acquire player session is here, this command is probably meaningless. it should not happen. There might be a race condition. Yeah. And now if like you created your character and so on, the server sends a game packet, which basically it doesn't have any data in it. It's just a packet which tells the client everything went fine, you are logged in, have fun, good luck. And we get to create the sending thread. Now the sending thread needs same stuff as I described in C++. The sending thread basically needs a synchronized queue. Synchronized meaning there will be no race conditions. It would be like it will have some mutex, which actually makes sure that one thread cannot interact with the queue and the other thread is interacting with it. Yeah, it creates the it creates a new thread which runs this method. Or is it a method? I think it's a method. It's a bound method at this point in time. And starts it, and yeah, it also remembers which gets the handle to the no, that's not true. In Python, it's actually a reference. Well, reference is an object, a label. Yeah, that's called a reference for the sake of simplicity. It's a reference to a thread object, and it does this. And this is basically how interact, because on the lower level in the networking code we have packets, right? But the higher level code actually can both process packets, but it also must be able to process different kind of events. For example, an event type might be event special, basic info request, which means for this player, the server must now send all the information which the player, the game state, basically the initial game state, to the client, which would be in this case where the client, where the player is located, which direction is it looking at, what does the player have in the inventory, what does the player have in the hands, like equipped, what is the state of the HP bar, what is the state of the mana bar, and like also, I guess, what is the name of a player and so on and so forth. So this is basically what the server must do. And as you can see, it doesn't really send it here. It just puts the event on the queue for the world to process. Now, I will get to the world in a sec, but keep in mind that the world, like the heart of the MMORPG, is actually a separate thread, which is getting... It's also one thread, only one thread, and it's getting packets. It's getting different types of events, and it tries to process them and update the world state accordingly, or not update it in some cases. And also, it is responsible for scheduling what has to be sent to what player and when. For example, if you have two players and one of them moves, then the other player needs to be notified that the player did move. So that's also what the world is responsible for, not only just updating it on the server, but also actually notifying the players in nearby that an event happened. And yeah, and this is a typical receiving loop. Like, you receive a packet, and if it's one of the types which are already used and can be used only at the beginning of the connection, then yeah, raise an exception because we don't know. But if it's a goodbye packet or a ping packet, then process it already here. Do not bother the world thread with it. And if it's not neither of these packets, then actually do post the event to put it on the queue for the world to process. So the world has only one event queue, and all the connections, all the different players put events on that queue, and the world thread is going to process it. Now, okay. Let's go to the world. Let's go to the world. Let's go see the world. Yeah, this is probably the longest file in the server, which isn't super long in all honesty, and it should be split into several files. But yeah, this is the world class, which basically is responsible for handling and keeping the state of the world and also processing incoming events and changing the world state accordingly. So how is it initialized? It's basically, well, it has a table of players, has a table of player sessions. These are for event handlers, but we'll get to that. We'll get to that, yeah. Then it has a storage for items, for actors, basically, mobile units. For the map, which is it is its own class, and it's kinda, this isn't beautiful code by the way, because this is the code which I was doing near the CTF. So a lot of code here is pretty ugly because I didn't have time to design it properly. So like for example, the packet parser I'm quite happy with, because that was designed at the beginning of a project, and this was like done more near the CTF, where I had to basically be fast, so I actually finished it by the proper time. Okay, now yeah, and it spans the main thread, which is again has this event queue, which it will be processing all the time, and then it just waits for the thread to finish. So let's go to the main thread, which is this thing. Yeah, again, this is the heart of the world. Everything is happening here. It has, now, as far as the events go, there can be basically 3 types of events in the queue. There can be packets, like just a network packet. Some client sent a packet and it needs to be processed by the world. It's already checked, it's already parsed, it just needs to be processed. Then there is the special one. For example, a new client has logged in, dear world actually sent a game state, the bootstrapping game state to the client so they can render the world and so on. And then there is the asynchronous type. Now, because there's only one thread which is processing all and every events in the world, this actually saves a lot of, like, simplifies the code a lot. That means that if I want to do something like this, I want to have an item, for example, like a teleportation ring, where I need to write something like doing something, so like write something, and then I want to sleep. I want to sleep like for 2 seconds, and then I want to write something else, like display a text message, for example, I am binding the ring to this location, and then sleep 2 seconds, and then send another message saying, yeah, the ring is now bound to this location, actually. So if I would sleep for 2 seconds in a function which handles this item and is being called in this main thread, that means it actually would, yeah, it would just freeze the whole world. Like, nobody could move for these 2 seconds. Like, nobody could do anything because it would be sleeping and waiting to write like that the teleportation ring is now bound, which doesn't make a lot of sense, right? So another way to do it is to handle the items in a separate thread, for example, and handle the casting in a separate thread, and so on and so forth. But this starts to require quite a lot of synchronization, mutixes and so on. And that might be actually an efficient approach, like have a thread which is responsible for items, have a thread which is responsible for spells. But I also would need to, the threads would sleep quite a lot while waiting, for example, for, I don't know, this item to become available because now a different thread is using it, or like even the item directory which has all the items in the world which exist in the world is sleeping because like this thread is actually like, I don't know, a player is creating a new potion and therefore another thread doesn't have access to it. So in the end, and also on top of that, giving the global interpreter lock in Python, then yeah, that would complicate the code a lot, and I didn't want to go that way. So how to solve the sleeping problem? And this, please note, this isn't only a sleeping problem, right? Because a different problem might be that the server actually, like, I don't know, I have an item which is like a scroll of unlock doors, like unlock a lock. And so a player uses the item, and now the player wants to pick which doors they want to like pick the lock for. And so the server basically needs to, like, the item processing code needs to ask the client, please point to a door which you want to pick. And then the client must say, like, oh, these doors were actually picked. So that would mean that, again, the code would wait for like an event, right, from the client when the client picks the door, and nobody else could do anything during that time. So it's not only about sleeping. And this could be solved actually in several ways. One of the ways is callbacks, like in JavaScript, right? In JavaScript, if you write code, then there are a lot of callbacks, which, like in old JavaScript, because that changed a little, where the like in this case, I would have one function which writes out the message binding teleportation ring to this location, and then I would have a callback which would be called in 2 seconds. So I would end my function here and say, like, timeout 2 seconds and call this method, and then something would after 2 seconds actually call the other method. And this is a mechanism which I kind of have implemented, but I didn't want to break it into 2 functions with callbacks, and because this actually might complicate code quite a lot, because it's easier just to write a code where I can just write sleep. So a different solution is fibers. Now, fibers, as you may know, is basically is user mode scheduling, which means that a thread is being run and it's executing some function, but that function says, okay, I need to sleep now, please go and do something else. So it calls a user mode function which changes, like saves the current state, and it changes to a different fiber. It's not a thread because everything is it's not running simultaneously in parallel. It's running in one thread. So yeah, then a different function might be run, and the function switches at will. So the function says, okay, I want to yield now. I want to yield the CPU. I want again to call the user mode scheduler and call a different function, like continue, for example, continue execution on that prior read function, right? So this is how fibers work, and this is how I actually implemented it. So the sleep would be, it's a little more complicated in Python. In C++, it would be just some mysleep, which would do that. But in Python 2, I actually had to use yield keyword, which you normally use for generators, right? But in the end, it's fibers, right? So yeah, so this is the async, basically. It means that there is a fiber which needs to be woken up at some point, because this also acts as a scheduler, right? It acts both as processing, like calling the handlers for the packets, but it also acts as a scheduler, so it keeps all the fibers which are active in basically a loop. And this is this event queue sleeping. To make it a little more efficient, I actually associate a timestamp where a given fiber has to be woken up, so that if a fiber is, just going to sleep for 5 seconds, then it will be put with a timestamp 5 seconds in the future, and until the server reaches that time, it will never try to wake up that fiber, because the fiber would just go back to sleep anyway, so that's just waste of cycles. So that's why that's implemented this way. Then I have another thing is catch packet request. Is basically, as I gave you the example of a scroll of lock picking, right? Which would be picking locks on a door, and the client would have to select which door do they want to pick. And in this case, the packet ID would be used, saying that the server sends, like, please select a door packet, and with a given unique ID in the packet ID field, and then the client would respond with the same packet ID saying, I want to pick these doors. And if that happens, then there's actually another mechanism for out-of-bound waking up a fiber. Well, it doesn't really wake up a fiber, but it could. But it's providing another another function which is already handling a different packet with the packet the function is waiting for, because it's actually a reply to something the function has initiated. So this is what the catch packet request is for. The function, which would be like please select the doors, would actually fill this this dictionary with a packet ID, and then with a packet ID comes, the packet would be passed directly to that function. It's a little more complicated, but it basically, that's the gist of it. Yeah, there's another like special event at the beginning, which basically initializes all the spawns for items and for mobiles. There are no mobiles in this game, but there could be. Yeah, and then there is the code which actually handles it. And this doesn't end until, well, somebody wants to exit the server, plus all the events which are in the queue are processed. So there's that. The way it works, I guess it's you can read the code, but it either tries to get a new event from the queue, or tries to, like for example, a packet which just arrived, a network packet, right, which is on the queue, or it tries to wake up a fiber if a fiber is ready to be woken up, and the rest of it is basically calling, well, a proper handler, which or actually in case of if a function is yielding, then it also is responsible to posting the event of an async type because of the way it's done. So, for example, what happens if a player wants to move? Because that's a simple example. So there is this packet which is called move, which means that the server will receive well, an event which is type ev packet with the packet of move, and then it calls the proper handler of a packet, and the handlers are implemented in the contents directory. So if we, oh no, that's not it. If we go here, it's in the server, and then it's in the content directory, and we have to go to sorry, it's not there. Quite a lot of stuff is actually implemented here, but like high-level stuff, like items and so on, but it's actually in the EV packets, like events packets, because moving is just a packet. Okay, so here's the code. Now, let me make, okay, where did it go? Yeah, Windows has a bug, by the way, but actually, at times, it really likes to move my windows off screen. I'm not really happy about it. Okay, here we go. Sorry. So we have this handle move. This is what happens when a player wants to move. Now, if the direction is different, like larger than 3, so it's not between 0 and 3, then actually exit, because the direction can be either 0, which is forward, 1, which is backward, or straight left or right, so that's 0, 1, 2, 3. If it's a different one, then just bail out. Return false, I don't think it does anything actually. It will not disconnect the player. It probably should disconnect the player, because the client is sending garbage, because this packet never should have a value in that field larger than 3. Then it, well, translate the direction, because forward doesn't really say whether it's north or is it east. It's forward, right? So it depends on where the player is looking, and also the direction where the player wants to go. So this translates it into an actual direction, which could be north, south, east, or west, right? Yeah, if you're wondering if I'm sitting north because I showed north this direction, then no, that's actually not north, but whatever. You know, you get the picture. And then we get a direction to vector, because the vector, you know, is 2 dimensions. For example, moving north means actually moving -1 in the y coordinate. Yeah, and then we consider the position candidate. We do not move the player yet, because we do not know if the player can move. For example, here, if I press W to move forward, I just move, right? But what if I would be standing next to some water, right? And I still press I want to move here, but this is water, so I cannot go there. what happens then. So this is why it's a position candidate, is not the new position. So yeah, first of all, it checks whether it's off the edges of the map. Because there are like at least several locations on the map where it's on the edge, and we don't want the player to stepping off the map. As you remember from my solving the challenges, one of the challenges was actually stepping or being pushed from the map, and that was in a spell called Shove, if I remember correctly. So the code there looked differently than this, but this is a proper check. It's just checking if somebody wants to step off the map, and if so, do not allow them to do that. And then it also gets the items which are placed on that location, because items, you might think of items as like this, like an empty flask, right? But item can also be like a magic field which is blocking your way, so you cannot go there because it's blocking. And in such case, this actually gets a list of all the items which are at the new position, and it checks if there are any items. For each item, it checks if the item is blocking. Because if the item is blocking, that means that the player cannot move there. And it says this actually sends a packet to the player saying, well, it actually schedules sending the packet to the player, which is saying like the way is blocked. If, however, the item type is door, then a door in this game is actually a teleport. So if you enter through a door, you actually get teleported somewhere else. Well, somewhere else being to an inside, or like to an inside of a dungeon, or to outside, where if you move out of a door. And like a teleport, like I don't know, like a gateway would also be a magical gateway, would also be a type of door. And this basically calls the teleport method of the given item, and that method is responsible for actually teleporting the player to the proper location. If it's like another item, or like there are no blocking items, no door items, then we move on. Then we actually calculate get the two-dimensional position to one-dimensional position, and we check what kind of a terrain is there in the world. Because if it's actually a blocking, for example, it's water, or for example, it's a building wall, or for example, it's a mountain wall, then the player cannot move on top of that tile. So yeah, returned false. I initially had like this looks deep, cold, and otherwise unpleasant, or looks pretty solid, in case you wanted to bounce off the water or bounce off a wall. But actually, if you'd be moving through the mountains, that would just spam your whole screen with messages, because that's, like moving through mountains is hard. So yeah, that's not really happening. And in the end, we actually have, we have this, which is, we get the odd player position because we need it. And then we call the method which is move. We move the player to the new position. And this is a map, so basically we move the player on the map, and the map is supposed to update it's like caches of where the players are and so on. Actually, in this implementation, there are no caches, but they're like on my to-do list. And then we send the new position to the player, because yeah, the player has moved, so the client can now render the new screen. If that was a teleport, well, actually, not really a teleport. If that was, well, yeah, whatever. It sends the position, and the player needs to redraw the screen and so on. Well, the client actually redraws the screen all the time, but now it needs to redraw it in a new position. But apart from actually sending the position just to the player, it also needs to broadcast the new position of the player and the old position of the player to every actor, every other character, not only player character, but also non-player characters. Because, for example, if you move somewhere where an enemy is nearby, the enemy might spot you. So this broadcast mobs is supposed to call a method in each of the actors to basically check if they spotted you, and maybe they want to move in your direction or something like that, right? That's not really implemented, but that's the idea behind it. And it needs to also update, like send the broadcast. it's not that the player moved there. It's basically send the new state of the world to everyone around. And that also means that if you just enter the teleport, then you might, well, other players will see you disappear, right? Because you entered the teleport or whatever. So that's why you need to actually update also the mobiles which were near where you left from. And that's basically it. Now, let's look at a different example. For example, if we want to use an item, well, no, using an item is trivial. Let's use spellcasting, maybe. Let's look at spellcasting. This is something I guess I already described, so it's going to be really short. I described it on the zeroth episode, right? Where I showed how to solve the tasks. And here, if we, for example, cast force ram, which is like shove spell, the push spell, then there is this. This is a method which basically yields. So it basically, at this point, for this method, as soon as this is called, the fiber jumps to the main thread again, sorry, to the main loop, the scheduler loop, which tries to get another event and so on and so on. So I basically wanted to show you that how the code is written. Now it looks a little weird because this is Python 2. In Python 3 you might like just write yield from and then like select or whatever. But here you have to actually do a for loop. This is a little like a for loop with a yield, and this is my addition due to reasons. Now, yeah, so I basically, when the client selects someone or something, or someone in this case, like another character, then we go here, which we just continue the function. We do not have to rely on any callbacks. We just continue it. There is a race condition possibility here, and it's pretty strong, but it's a more predictable race condition than it would be if we would be using multi-threading. So that's it. And that's basically it when it comes to the server. There is not much to it. There is the code which handles the map, the items, but you know, like manages where it's located, but it's not really a long code, so sorry. So yeah, so that's basically it. So if there are any questions, let's take them now. And apart from that, that would be, I guess, the end of the description how Arcane Sector Online was created. Now, as for my plans for it, I do hope to be able to use the game on another CTF, and maybe I will spend some time to actually like finish it a little more, you know, add some actual map, actual monsters and so on, so you can play it online somewhere. But yeah, let's see how much time I actually have. So let's take a look at the question. So the supervisor writes that, can you do return-oriented programming in Python, jumping to different returns inside the Python code? No, not really, because in Python you have once you enter a function, then you have like return-oriented programming in C or C++ works because all the code is in one memory space. Like, you know, you need to know the address, but it is in one memory space. So you can change like the address, which is the return address to this function, to some other function because it's all in the same memory space. Now in Python, that's not the case. In Python, actually each function has its own memory space for the code. And that means that if that would be possible, you could use only gadgets from one function, and you could not reach another function by changing the PC, the program counter, because the program counter would actually be related to that given one stack in the call stack of a program. So yeah, in Python it's probably not doable. That being said, I really like the idea. Yeah, so that's really cool. Maybe we should think about it. And another question is, why do you use braces instead of square brackets? Where do I use braces instead of square brackets? I'm kind of out of context here, so if you could help me out. but because I'm not really sure what does the comment refer to. Maybe some place here. No, I don't know. Like, message me later on, so we'll see. Okay, that's actually it for questions today. I guess this was the third part of like describing some long code, but I did really want to have it on YouTube, so second point folks too. So yeah, thank you for basically being here up until the end, and thank you to Disconnected, who was and is my moderator today, for the help. Apart from that, I do recommend joining our IRC channel. It's actually semi-active through the week. There isn't a lot of going on there, but I hope that changes one day. So totally do join it. Okay. Yeah, so that's it. There's a mission today, but it's the same mission which was last weekend and last 2 weeks. So if you're into writing bots for old school games, totally check out the mission. It's totally worth it. And that's it. Happy New Year, because with some of you I will not see you this year anymore. Next live stream will be either in the first week of January 2019 or in the second week of January. I am still checking my schedule to basically decide what I'm going to do at that time and whether I will be near a computer to be able to do a live stream. But well, one way or the other, see you in January. And that's it. So thank you and happy hacking, and I wish you all the best. Bye bye. And I'm going to leave you with some music as usual.